now, what can I do with that fraction? I can reduce because the whole number 4, the whole number 2, and the whole number 4 in the denominator are all reducible by 2. So x was equal to 2 plus or minus the square root of 2 over 2. No completing the square, no factoring. Simply writing out a formula, plugging in numbers, and doing math. On the test Thursday, you're going to be able to choose whatever method you want to use to solve the equations. Okay?
We can use that.
Yep. Works for every quadratic equation.
What was that other formula? Like ax squared?
That's not a formula. That's just the standard form of your quadratic formula. I'm trying to show you where A, B, and C come from. Okay? Okay. What's the problem with this one right now, the way it's set up? It has to equal 0. Okay, so when I subtract 5 from both sides, A is going to still be 1, B is going to still be 3, but C will be no 3. When you subtract 5, B is equal to, C is equal to 3. When you get to this point, how many roots do I have to this equation? 2. -3 plus whatever, and -3 minus whatever. There are 2 answers here. 2 roots. What kind of roots are they? Are they rational, irrational, or imaginary? They're imaginary. Okay? They're imaginary. And from the chart that you would have found, you can know just by looking at this number what kind of roots you're supposed to be finding. Why do you think if this is negative, it tells me I'm going to have imaginary roots? Because you're taking the square root of a negative number, which is imaginary numbers. All right? Okay, let's see if we can spice it up a little bit. Oh. If this happens, what does that mean? C is 0. Plug everything in, but C is 0. And you still got to solve. Okay?
It'd be easier.
It would be so much easier to factor, wouldn't it? Which is why we also learned how to factor. Because right now, if I just factor this, so x is 0 or -8. Okay? Factoring was so much easier this time. All right. spice things up a bit. Oh, I hear all the deep breaths. Okay, as long as it's in an equation, you can multiply every term by anything and create an equivalent equation which will give you the same answers. So, if I can multiply every term by any number, why don't I multiply by a number that will allow me to get rid of the fractions? What number would allow me to multiply and get rid of fourths and thirds? 12. 12. You got to multiply by a number that 4 and 3 go into, which is 12. So since it's an equation, if I'm going to do that to one or two terms, I've got to do it to all terms. So here, if I multiply by 12, here multiply by 12, here multiply by 12, and here multiply by 12. What does this first one become? 9x squared. What does the second one become? Minus 4x. Minus 12 equals still 0, because 0 times 12 is still 0. And now you don't have fractions, because A is 9, B is negative 4, and C is negative 12.
Wait, you don't multiply? Oh,
36 over 4.
How do you get x squared? Oh, I see hard.
I'm sorry, Nick Parker just looked at you like, is he serious? Yeah, that's part of the problem. All right, so y'all work that one out. And then I have one more example, and we will be done.
So why did you multiply the top?
Because I'm trying to cancel the denominator. I'm trying to make the denominator go away. And so I'm multiplying by a whole number 12. Okay? Well, when you multiply by 12, using the time sign, it's understood 12 over 1. So this is what's being multiplied and this. All right, this problem required us to be able to reduce a radical, multiply, know how to reduce the fraction at the end.
Why didn't you just take out 2, 4? You took out all 3.
I'm looking for pairs,
And you took out
which this is a pair of 2s, this is a pair of 2s, and this is a pair of 2s. So 2 times 2 times 2.